The chain rule can be written out a bunch of different ways. I think one of the clearest ones is this one, where you take a function f of x and think of it as a composition of two functions, g and h, so g of h of x. The chain rule says that the derivative of f prime of x, is going to be g prime of h of x times h prime of x. Alright, no matter what notation you're using, I think it's always kind of abstract to look at it this way, so let's just do a few examples. Start with an easy one. We'll make f of x x squared minus 1 all raised to the 4th power. Alright, what the chain rule says is you're sort of applying the power rule to the thing inside parentheses here. In other words, you're taking the 4, you're bringing it out front, you're subtracting 1 from the exponent, so it becomes a 3. And then we have to just tack on the derivative of what's inside the parentheses. That's this h prime of x up here. So the derivative of what's inside here is 2x. And at this point you're done. This is the derivative. If you want to simplify a little bit, you can bring this 2x to the front. So you'll have 8x times x squared minus 1, the whole thing cubed. Here's another example. F of x is 3 times the square root of 4x cubed minus x. I think a good rule of thumb is to, if you're trying to take a derivative and you've got a radical in the function somewhere, rewrite it as an exponent instead. In other words, rewrite this as 3 times 4x cubed minus x to the 1/2 power. Alright, now let's take the derivative. The 3 is a constant, so we'll just leave that out front for now. Now, we're applying the chain rule sort of in conjunction with the power rule. So we've got this thing in parentheses to the 1/2. We're going to apply the power rule, in other words, bring the 1/2 out front. You've got in parentheses 4x cubed minus x. You want to subtract 1 from this exponent, so you're going to have 1/2 minus 1, which is negative 1/2. And now we just need to multiply all this by the derivative of what's inside these parentheses. So the derivative of 4x cubed is going to be 12x squared. The derivative of x is 1, so we've got that. And at this point you're done. I would just, to make things a little bit simpler, combine these two terms. So you've got 3 over 2 times 4x cubed minus x to the negative 1/2 times 12x squared minus 1. Here's a slightly more complicated example. F of x is going to be 3x divided by x squared minus 2 cubed. Alright, so now we're going to apply the chain rule, but we're going to do so within the quotient rule, right? Because f of x here is written as a quotient. Alright, so first let's establish u and v and their derivatives. U is the numerator, so that's going to be 3x. V is the denominator, that's x squared minus 2 cubed. The derivative of u is pretty easy, it's just 3. The derivative of v, though, requires that we use the chain rule, right? Because you've got something in parentheses to a power. So we'll first apply the power rule, bring the 3 out front, subtract 1 from it, and then multiply on the end by the derivative of what's in the parentheses. In this case, 2x, right? The derivative of x squared is 2x, the derivative of 2 is 0. Okay, I'll simplify this just a little bit more since we're plugging in, and it'll be easier to look at that way. Just bring this 2x to the front, and I've got 6x x squared minus 2 squared. Okay, now let's plug everything in to the quotient rule. The quotient rule says that on top we've got v times u prime, so it's going to be x squared minus 2 cubed times u prime, which is 3, minus u times v prime, here's v prime, 6x times x squared minus 2 squared, and this is all over v squared, right? So for now, let me put that in brackets. So we've got x squared minus 2 cubed, and we're squaring that whole thing. Okay, let's see if we can simplify this a little bit so it's a little less messy. This 3 I can't really do anything with. I'll just bring it out front. So I've got 3x squared minus 2 cubed. Remember, since the thing in parentheses is being raised to a power, I can't just bring the 3 inside, right? So we'll just leave it out front. Okay. Now we can, for these terms over here, we can't bring these inside these parentheses because it's being squared, but we can at least combine these two front terms. So you've got 3 times 6, which is 18, x times x, which is x squared, and then we've got x squared minus 2 squared. And in the denominator, we've got something cubed and then squared. So if you've got something to a power and you raise it to another power, you multiply the two exponents together. So that'll give us 3 times 2, which is 6. Okay. And again, at this point you are done. This is the derivative. But the simpler that we get things, the easier it'll be to plug stuff in later on down the road. Okay, so I'll simplify a little bit more by doing the following. If you notice in each of these two terms up top, I've got an x squared minus 2 to some power. So I'll factor out as many of those as I can, right? Now, in the first term I've got 3 of them. I've got x squared minus 2 cubed. In the second term I've got 2, x squared minus 2 squared. So I can factor 2 of them out. In other words, I can bring out an x squared minus 2 squared. And then I'll have whatever's left in brackets. Right, so that's going to be 3 times x squared minus 2. Right? If there were 3 of these here and I factor 2 of them out, I'm left with 1 of them. And then over here, the second term just becomes 18x squared because I factored both of these out. Alright, so when you're doing that step, since you are watching this video, why don't you pause for a second and make sure that this step makes sense to you. In other words, if you were to go backwards, multiply this back into these brackets, you see that you would end up with this again. Alright, the denominator is still the same. We've got x squared minus 2 to the 6th. Okay, now there's even more simplifying that we can do. If I take these two and cancel them out with 2 of these guys, in the denominator I'll be left with x squared minus 2 to the 4th. And now let's see what we can simplify up here. Now there's no power on this term in parentheses, so I can actually multiply the 3 through, giving me 3x squared minus 6. Then I've got this minus 18x squared term. Now we'll simplify a little bit more by combining like terms, and then we should be done. So 3x squared minus 18x squared is going to give us minus 15x squared, and we've got minus 6, and this is all divided by x squared minus 2 to the 4th.